Section 6.3 is titled Exponential Functions. Every problem in section 6.3 is going to have function notation. If you see the first two problems from section 6.3, they have function notation, hence they're going to be functions. And the word exponential implies the variable that's to the right of the equal sign is in the exponent. So these are examples of exponential functions because they have function notation and the variable is in the exponent. The first few problems just want us to graph functions and identify some of the features of the graphs of the functions, and this is really easy to do. For the first two problems, these are exponential functions. I'm going to make a table of 5 points, meaning I'm going to put 5 values in the x column and find y's and plot those. And to get started with the graph of an exponential function, usually you set the exponent equal to 0 to get the number for the middle of the x column. So for this problem, when I set the exponent equal to 0, that's just going to give me x equal to 0. I'm going to put that number right in the middle of my x column, and then I'm going to go bigger a few and smaller a few. And those are the 5 values I'm going to use in my x column for my table. And then my y's, I'm going to get by plugging those numbers into the function. So the first y I'm going to get by plugging -2 into the function. I'm going to find out what f of -2 is. That's going to be 3 to the -2 power. And I should remember that that's 1 over 3 squared. You can make negative exponents positive by creating a fraction with a 1 in the numerator, with the exponent turned positive in the denominator. And 3 squared is 9. So the first point I'm going to plot is -2 comma 1/9, and that point is just above the x-axis. In fact, I'm not going to get any points on the x-axis or beneath the x-axis because it's impossible to plug a number into this function to get 0 or a negative number. If you plug a positive number in, you'll get positive numbers. If you plug negative numbers in, you'll actually get positive numbers that are fractions. So the graph will never ever touch nor dip below the x-axis because this function, it's impossible to plug a number in for x and get 0 or a negative number. Most exponential functions have that property that there's not going to be a number that you can plug in to get a 0 or a negative number. In fact, all exponential functions will have that property. Most is kind of an understatement. So I'm going to continue graphing this by finding some y's. The next y I'm going to get by plugging -1 in for x. That's going to be 3 to the -1 power, which is 1 over 3 to the first, which is 1/3. So at -1, I'm up 1/3 of the way between 0 and 1, and that's a little under halfway. It should be a little bit higher than 1/9, but not that much higher. The third value of x I'm finding a y for is 0. That's going to give me 3 to the 0 power, and we say anything to the 0 power is 1. So now I'm going to get the point 0, 1. The fourth point, I'm going to plug 1 in, get 3 to the first power, and that's 3. Then I'm going to plot the point 1, 3. And then the last point, f of 2 equals 3 squared, and 3 squared is 9. So the last point I'm going to get is 2, 9. So this graph on the left-hand side is going to really get flat. The y's, if I was going up further, Negative 3 would be 1/27th, negative 4 would be 1/81st, negative 5 would be 1 over 243, negative 6 would be 1 over 729. The y's are going to get so close to the x-axis that you can't distinguish the x-axis from the y's. The graph's going to get microscopically close to the x-axis, going off to the left, but it's always going to be barely above it, even though my graph is, because of the thickness of my ink, looks like it touches it. It's actually slightly above the x-axis, or it's supposed to be, because the y's are all supposed to be positive. And then off to the right, it shoots up really high. So this is part A of number 2, making a table of values and sketching a graph. All exponential functions, when I go to do part B, have domains of negative to positive infinity because they exist from the far left edge to the right axis, and if you go up and to the right far enough, to the far right edge of the x-axis, unbroken. So the domain of every exponential function is going to be negative to positive infinity because they exist everywhere from the far left to the far right edge of the x-axis, and there's no work to do for those. The range is a little bit trickier, so I'm done with 2b. Moving on to 2c. For the range, I need to identify the bottom of the graph. The bottom of the graph is the x-axis, which has a y-coordinate of 0. The top of the graph is the top of the y-axis, which has a y-coordinate of infinity. For the range, I'm going to start at 0, and I'm going to end at infinity. This 0 that it's going to start at, which is the bottom of the graph in terms of the y's, is going to get a round bracket, because if you gave it a square bracket, that would imply there's a point on the x-axis, or that there was an x-intercept, but there aren't any points that have a y-coordinate of 0. So when I go to sketch this point, or make this range, I'm going to make it 0, infinity. And then the next question that I asked, so we're done with part C, is part D, the horizontal asymptote. This graph really only has a horizontal asymptote at one side, and the x-axis is the horizontal asymptote, at least to the left here of the origin. To the right, the graph doesn't track that horizontal line, but to the left of the x-axis, of the y-axis, the graph gets microscopically close to the x-axis without touching it. So we'll say the horizontal asymptote is the x-axis, and we learned in the last chapter that the x-axis has the equation y equal to 0 when we were graphing fractions. If you just said the horizontal asymptote was the x-axis, I'd live with it, but it's not really the best answer. So you should do the same thing for problem 2. Your graph should look really similar. I'll move on to do problem 4, and you can do problem 3. For number 4, I'm going to take the exponent and set it equal to 0. The first thing I need to do in number 4 is make a table of values and sketch a graph. I'm going to set the exponent equal to 0. And when I go to make my table, that's the number I'm going to put in the middle of my x column. So in the middle of my x column, I'm going to plug negative 3. That's what I get when I take the exponent equal to 0. And then I'm going to go negative 4, negative 5, negative 2, negative 1, making 5 numbers in my x column. And then I'm going to get my f of x column. And this is going to be real similar to the other f of x column because the base is the same. So for the first y, I'm going to plug negative 5 in for x and get f of negative 5 equals 3 to the negative 5 plus 3. That's going to be 3 to the negative 2 power. That's 1 over 3 squared, and that's 1/9. So that's going to be the point negative 5, positive 1/9, just right above the x-axis at negative 5. The second value, f of negative 4, I'm going to plug it in for that x and get 3 to the negative 4 plus 3. That's going to be 3 to the negative 1 power, which is going to be 1 over 3 to the first power, which is going to be 1/3. So negative 4 comma 1/3 is going to be less than halfway up, less than half, but above the x-axis, above the first point. Third point, f of negative 3 is going to be 3 to the negative 3 plus 3. Again, just plugging negative 3 in for that x. That's going to be 3 to the 0 power. Anything to the 0 power is 1, so now I'm going to plot the point negative 3, 1. Fourth point, f of negative 2. F of negative 2 equals 3 to the negative 2 plus 3, which is 3 to the 3 to the positive 1, which is 3. So negative 2, positive 3. And the last point, f of negative 1 is 3 to the negative 1 plus 3. That comes out to 3 squared, which is 9. I kind of construct these tables so my y's start to duplicate. Just like the last graph, exponential functions, you're never going to get 0 for a y value, nor are you going to get a negative number for the y value. So the graph going off to the left should stay just microscopically above the x-axis. And then going off to the right, it gets really high really quick. The next point in this list would be 0, 27, then 181. So it gets super high super fast. So this is done. This is part 4a. This is my table of values and making a graph. For part B, the domain of every exponential function, because they exist all the way to the far left edge and to the far right edge of the x-axis, the domain of every exponential function is negative to positive infinity. It's nice if you put arrows at the end of the graph to just signify that it keeps on going, but if you don't write the arrows, it's not such a big deal. The range of this is going to be the same as the last one, because this bottoms out. It doesn't have a y that even touches the x-axis. The bottom of the graph is just above the x-axis, which has a y-coordinate of 0. The top of the graph goes to the top of the y-axis, which has a y-coordinate of infinity. The range is going to be 0, infinity. The 0 is going to get a round bracket because there's no point that's on the x-axis. I have the same horizontal asymptote, meaning this graph, at least off to the left of the y-axis, gets microscopically close to the x-axis, and the x-axis is the horizontal asymptote. The equation of the x-axis is y equal to 0. So that's everything for the kind of by hand graphs. The rest of the graphs that we're going to do is we're going to do some shifting to create the graphs and not do tables of values. So for each of the problems between 5 and 16, you're given a graph. I'm given the graph of f of x equals e to the x. I'm given a table of values, and I'm given 5 points on that graph. In problem 6, I'm asked to find f of x minus 5. That's the first thing I need to do. So the function that's given to me for each problem between 5 and 16 is f of x equals e to the x. And 6a, I'm asked to find f of x minus 5. When we're dealing with most functions, if the x minus 5 was in a parentheses, when you found that function, you'd put that x minus 5 in a parentheses, replace the x with that x minus 5, and put the x minus 5 in a parentheses. This would be perfectly fine for the answer to 6a, the find each function. When there's subtraction or addition in an exponent, the exponent kind of works as a parentheses, and you don't really need the exponent. So this would be considered an okay answer for my find each function. But it would be better if I answered 6a and I just said f of x minus 5 equals e to the x minus 5. That would be completely adequate for an answer. Now I need to describe the transformation. Well, the rules for transforming are exactly the same. So if we have f of x plus some number in a parentheses, that's going to move the graph left. F of x minus some number in a parentheses is going to move a graph right. F of x plus some number after a parentheses moves the graph up. I just changed the letter just because I just instinctively did that, but I could use h for all of these. I have in the past. F of x minus some number moves the graph down. F of negative x is going to reflect it over the y-axis, and negative f of x reflects over the x-axis. So I kind of have to have those memorized from what we did earlier this semester, and we did a decent number of these. So to describe the transformation, because I was finding f of x minus 5, that's going to move the graph of f of x to the right 5. So I'm just going to say right 5. Now the ugly part that I should have a really nice sharp pen, maybe something new even. I'm not sure if I have anything new that's going to be that sharp. So to graph f of x minus 5, if you're given a graph and you know the transformation, probably the easiest thing to do to sketch your graph is just to take each point and move it 5 to the right. So this point that's on 2 and a little bit above 7, I'm going to move it 5 to the right. 2 plus 5 is 7, so it's going to move over to 7. If you counted 1, 2, 3, 4, 5 over, you'd get that point there. This point that's at x equal 1 and a little under 3, I'm going to add 1 to 5 to get to the right 5. That's going to put it at 6, counting 1, 2, 3, 4, 5 to the right, and it's going to be a little under 3. This point that's at 0 on the in terms of the x, if I move it right 5, it's going to go to 5, and it's going to be right at 1. This point that's slightly above the x-axis at -1, I go 1, 2, 3, 4, 5 to the right, move it there, and this point I move it 5 to the right, and it's going to go there. So I'm just going to take each point and drag them 5 to the right. Off to the right, this graph's going to go up and get really high, but off to the left, the horizontal asymptote is going to stay. This graph doesn't get shifted up or down, so it just gets moved over. And this part that's touching the x or just above the x-axis is going to stay just above the x-axis. So that's a reasonable graph for this function. I use the transformation to sketch the graph. This is still an exponential function. All exponential functions have domains of negative to positive infinity. And this range is going to be the same. This graph, it has a horizontal asymptote at the x-axis. The x-axis has an equation of y equal to 0. The equation of the horizontal asymptote gives me the start of the range for this. The range is going to start at 0 and go up to the top of the y-axis at infinity. The graph is always supposed to be microscopically above the x-axis, even though it looks like it's touching the x-axis. That makes this get a round parentheses as opposed to a square parentheses. You're supposed to do exactly the same thing for question 5. Ultimately, I'm going to do a bunch of graphs. If for most of the problems you do parts A, find the requested function, part B, describe the transformation, part D, E, and F, do the domain, range, and horizontal asymptote. If you don't graph each and every function, maybe you graph, graph 5, don't graph 7, graph 9, don't graph 11, graph 13, don't graph 15. That's going to be fine. You don't need to graph every function because it gets kind of be tedious to do. So for part 8, I'm going to find each function. For 8a, to find the requested function, the function I'm starting with is f of x equals e to the x. I'm finding f of x plus 4. The x plus 4 is in a parentheses, so I could leave that x plus 4 in a parentheses and put it in the exponent with the x, and that's an okay answer. A better answer for the find each function for part A would be f of x plus 4 equals e to the x plus 4 without a parentheses. The exponent kind of works like a parentheses. Now I'm going to describe the transformation. Because that plus is in a parentheses, it's going to move the graph left 4. Because I have the graph at my fingertips, it's going to be pretty easy for me to sketch a graph. I'm just going to take each point and move it to the left 4. So this upper point, I go 1, 2, 3, 4 to the left. Make it at the same height, just a little bit above the 7. I made it a little bit low, but it's good enough. That point a little bit below the 3 and go 1, 2, 3, 4 to the left. This point right on the 1, 1, 2, 3, 4 to the left. This point just a little above the x-axis, 1, 2, 3, 4 to the left, and that point 4 to the left. And I'm going to connect these the best I can. Will look something like that. Still have that horizontal asymptote at the x-axis. So for using this graph transformation, I'll just say see below to sketch my graph. The domain is the next thing I need to find. All exponential functions have a domain of negative to positive infinity. Because like the first 3 graphs, this one bottoms out at the x-axis. It has a range of 0 to infinity. And the horizontal asymptote is the x-axis, which has an equation y equal to 0. It doesn't matter to me if you draw the horizontal asymptote in. It's not necessary to draw it in. It's kind of nice to have it. I don't think I drew it on the last one. It doesn't make it the graph wrong. It's just I didn't take the time to emphasize that feature because I wasn't asked to emphasize that feature. But since I was asked to find it, it doesn't hurt to draw it. So you should do the same thing with number 7. You're going to find the function and do the shifting. Again, if you don't want to graph everyone, that's completely fine. For 10, to find each function, because I'm finding f of x plus 3, the original function is f of x equals e to the x. To find f of x plus 3, because that plus 3 is not in a parentheses, the plus 3 doesn't go in the exponent, it goes after the function. And when it's f of x plus a number, it moves the graph up. So this graph, when I describe the transformation, is going to be moved up 3. This is a little bit harder for me, but I can do this. I'm going to take every point and move it up 3. This point that's just above the x-axis, which is just above 0 in terms of the y, is going to go up 3 to be just above 3. This point's going to be a little bit higher than the first point. This point that started at 1 on the y-axis, when I move it up 1, it goes up to 4. This point that's a little under 3, when I move it up 3, is going to be a little under 6. I'm just counting up 1, 2, 3. This point that's a little above 7, I'll go 8, 9, 10, and it'll be a little above 10. So when I go to sketch my graph, I took every point and moved it up 3. So that was 1, hold it, above 7, above 8, that's okay. 1, little above 3, that's okay. 1, yeah, that feels fine. The graph doesn't look like I want it to look, I guess. It should look something like that. Let me do this on my calculator to make sure my graph makes sense. Let me graph both functions with a nice standard window to see how they should really look. So y equals, clear out all this stuff from when I was graphing before. I'm going to enter the function second ln e to the x, and then second ln e to the x, close out my parentheses, and plus 3, and do a zoom standard. It's going to do a better graph than I'm going to do here. It does kind of do exactly that. So what I have drawn here doesn't feel so bad. I mean, I didn't like the way it was looking, but I guess that's how it needs to look. I just moved every point up 3 and made the same shape. So done with parts A, B, and C. I found the requested function. I described the transformation. I sketched my graph. The domain of all exponential functions are negative to positive infinity. This function, because it got raised up, the horizontal asymptote that started at 0, it got raised up too. The horizontal asymptote that started off at the x-axis, because the whole graph gets raised up, the horizontal asymptote gets raised up with it. The horizontal asymptote is going to be y equal to 3. And when I go to find the range of this, the range is going to be 3 to infinity, because the graph bottoms out at y equal to 3 and goes up to y equal to infinity. Just like the graph should have a round parentheses for the 0 to infinities, for the range, it's going to be a round parentheses for this, because the graph will actually never touch that horizontal line, even though my graph kind of looks like it touches it. All right, so give 9 a go. So I'll do number 12. To find the requested function in part A, the original function is f of x equals e to the x. I'm finding f of x minus 4. That minus 4 is just going to be after the function and not in the exponent. To describe the transformation, f of x minus some number is going to move the graph down. Now I'm going to take every point and move it down 4. So this point that's just above 7, I go down 1, 2, 3, 4. It'll be just above 3. This point that's just below 3, I go 1, 2, 3, 4, moves down to there. This point that's at 1, I go down 1, 2, 3, 4. This one that's just above 0 goes down 1, 2, 3, 4. And this one's a little bit lower than it. So graphically, the horizontal asymptote gets moved down to negative 4 because it shifts everything down. And the graph's going to stay just above the negative 4. So that's a reasonable graph. So I can say C below for my graph if I care to. When you move a graph up or down, it doesn't impact the domain. The domain of all exponential functions are negative to positive infinity. Moving the graph down moves the horizontal asymptote down, and that impacts the range. The horizontal asymptote in this case goes down to y equal to negative 4. The the number in the horizontal asymptote is the start of the range, and the range ends up at infinity. All right, I might try to do both 13 and 14 on the same page here so you can see them both. 13, to find f of negative x, so for 13a, f of negative x, when f of x equals e to the x, you can just say it's e to the negative x and put the negative x in a parentheses. But when the letter's in an exponent, you really don't need the parentheses. So that's f of negative x. And f of negative x is going to reflect the graph over the y-axis. When I describe the transformation, I'm going to say it reflects over the y-axis. Now, each point needs to be moved to the opposite side of the y-axis. This point that has a y-coordinate of 2, when it moves to the opposite side of the y-axis, is going to go on the line y equals negative 2 at the same height. This one has an x-coordinate of 2. It's going to move to the opposite side to have an x-coordinate of negative 2. This point that has an x-coordinate of 1 is going to move to the opposite side and have an x-coordinate of negative 1. Points on the y-axis, when you reflect over the y-axis, stay on the y-axis. This one that has an x-coordinate of negative 1 is going to flip to the other side and have an x-coordinate of 1. This one with an x-coordinate of negative 2 is going to flip to the other side and have an x-coordinate of 2. So the graph of f of negative x, the graph that's reflected over the y-axis, looks something like that. For the domain of all exponential functions are negative to positive infinity. The range, because this thing still bottoms out at the x-axis, since it bottoms out at the x-axis, the range is 0 to infinity. It didn't get moved up or down, so the horizontal asymptote is still y equal to 0. That's everything for problem 13. So these were all problem 13. If I wanted to do problem 14, to do negative f of x, that's just going to be negative e to the x. And what that's going to do, it's going to reflect the graph. So that's 14a. To do part b, to describe the transformation, it's going to reflect over the x-axis. So every point is going to stay where it was at when I go to do my graph, but on the same vertical line, but now go beneath the x-axis if it's above, and all these were above, so they're going to go beneath. This was just above 7. Now it's going to go just below negative 7. This one was just below 3. Now it's going to be just above 3. This one was at 1, it's going to go down to negative 1. This one was just above the x-axis, it's going to be just below the x-axis. And this one's even going to be closer to the x-axis. So I took each point. If it was above a line, I made it below the line. If it was below a line, I made it above a line. And now I'm going to sketch my graph. I still get the same horizontal asymptote, but the graph approaches it from the bottom of the horizontal asymptote. For the domain, all exponential functions have domains of negative to positive infinity, as does this one. This is the first one where the range is really messed up, because for the range, I read from bottom to top, and this graph goes to the bottom of the y-axis, which has a y-coordinate of negative infinity, and it tops out at the y-axis, at the x-axis, which has a y-coordinate of infinity. This range is actually going to be negative infinity to 0, because I read bottom of the graph to the top of the graph. The bottom of the graph goes down to y equal to negative infinity. The top of the graph goes to the x-axis, which has a y-coordinate of 0. And for 14, the domain was D, the range is E, and for 14f, the horizontal asymptote, flipping it over makes it approach the horizontal asymptote from the bottom as opposed to the top, but it's still the same horizontal asymptote. All right, the next two problems, because they're not rigid transformations, because they're actually going to distort the graphs a little bit, I can't just move the same way. So let me do problem 16 real quickly. So for 16a, the initial function I'm working with is f of x equals e to the x. I'm asked to find 3 times f of x. And I'll just say that this is 3e to the x. With parabolas, when you multiply by a number bigger than 1, you usually say the graph gets narrower. This graph is it's going to be hard to see that it gets narrower. So I'm going to say if you multiply by a number greater than 1, that we're going to say it gets stretched. For some of the parabola problems, I said it gets stretched or the graph gets narrower. And just because you're not going to be able to see narrower because it doesn't have 2 sides to it. So I'm going to say it gets stretched if I multiply by a number bigger than 1. And if you multiply by a number that's in between 0 and 1, instead of saying that it gets wider, we're going to say it gets compressed. So for parabolas, it was real easy to see if they got wider or narrower, and I use those words to describe the transformation. Here I need to use the word stretched and compressed. I flashed those words but didn't use them that much in that section. So this graph, because I'm multiplying by a number bigger than 1, is going to be stretched. We can say it gets stretched vertically, but that's getting to be overkill. I can't really use the transformation so well to sketch a graph. What I'm going to do, because the number is being multiplied by the f of x and the f of x is the y, what I'm going to do is I'm going to take each x that's in my table, -2, -1, 0, 1, and 2, and I'm going to find 3f of x by just multiplying 3 by the y. This means take 3 times the y. So each number in the y column, I'm going to multiply by 3. So go off to my main screen and do 3 times 0.14. My first y is going to be 0.42. Second one, I'm going to go 3 times 0.37. What I'm doing is I'm taking the 3 that's in front of the f of x and multiplying it by each one of these, and I get 1.11. Then I do 3 times 1 and get 3. So I did 3 times 0.14 to find 3f of x, 3 times 0.37, 3 times 1, which is 3. Then I'm going to do 3 times 2.72 and 3 times 7.39. So this is called a non-rigid transformation, so I just can't move points like I did for the beginning problems. So those are the points I'm supposed to plot, and you'll notice that all the y's are still positive, and this graph doesn't get shifted up or down. It just gets stretched. The points get stretched, but then I'll show you what happens when I graph it. So the point -2.42, this point gets stretched a little bit away from the x-axis, but not that far. And then -1.11, this point gets stretched a little bit further because it was a little bit farther from the x-axis. The farther a point is away from the x-axis, the more it gets stretched away from the x-axis. The closer a point is to the x-axis, the less the stretching does to it. And then that point goes to 8.16. And this point goes to 22, which is maybe up there somewhere. And so the points that are really close to the x-axis, they stay pretty close to the x-axis. So the graph doesn't get stretched as far when the points are close to the x-axis, but when the graph's points are away from the x-axis, it gets really stretched. This graph's still going to have the same horizontal asymptote. It doesn't get shifted up or down, and the points get stretched, but once they're really close to the x-axis, the stretching gets really minimal. So to find the rest of this, to find the domain of all exponential functions are negative to positive infinity. This graph bottoms out at the x-axis, so it has a range of 0 to infinity, and the horizontal asymptote is still the x-axis, which is y equal to 0. I can't imagine putting something like 15 or 16 on a test, so we're probably not so concerned about that. The next 15 or so problems are much easier. They give me a function, the function that's given for each of the problems between 17 and 32, as g of x equals 2 to the x, and we're asked to part A, find each function, and part B, describe the transformation, but we don't have to do any graphing. So for part 18a, to find each function, because the x plus 3 is in a parentheses, I can say g of x plus 3 is 2 to the x plus 3, leaving the x plus 3 in a parentheses. That would be a correct answer for 18a, but when the adding or subtracting is in an exponent, the parentheses isn't really needed. The exponent kind of works as that parentheses. So this would be the better answer for 18a for finding each function. And for describing what happens here, this graph is going to be moved to the left here because the number added is in the parentheses, so the transformation is going to be left 3. For part 20a, to find each function, since the g of x function is 2 to the x, to find g of x minus 4, I could leave that x minus 4 in a parentheses and write 2 to the x minus 4, but that parentheses isn't needed, and it would be better to say g of x minus 4 equals 2 to the x minus 4 without any parentheses. When I go to do part B, because I have a minus inside a parentheses, the graph is going to shift to the right. So I'm going to say it's going to go right 4, should I say. So you should be able to do 17 and 19. For the next few problems, for 22a, since the g of x function is 2 to the x, g of x plus 3 with the plus 3 not in the parentheses, we'll just have the plus 3 after the 2 to the x function. So that's all there is to do for 22a. These problems are really short. And for the transformation, adding a number after a function moves the graph up, so I'm just going to say it moves it up 3. For 24, part A, the g of x minus 5 is just going to have the minus 5 after the 2 to the x function, so I'm going to just say it's 2 to the x minus 5. 24b, to describe the transformation is going to move it down 5. Don't have to make any table of values, sketch any graphs. I don't need domains, ranges, or horizontal asymptotes. For your problem 25, you're going to have a reflection over the x-axis. The negative is just going to go in front of the function. For my problem 26, I'm going to have a reflection over the y-axis, and the negative is going to go in the exponent. So just in case you're not clear of your answer to part 25a, part 25a, because the g of x function is 2 to the x, negative g of x is just going to be negative 2 to the x, and it's going to reflect over the x-axis. My function in 26, because the negative's in the parentheses, g of negative x would be 2 to the negative x, and I could change the x to a negative x and leave it in a parentheses, but it would be better, because the parentheses aren't really needed in the exponent, to write 2 to the negative x like that. And for my transformation, mine's going to reflect over the y-axis. When you do problem 25b, you're going to say it reflects as over the x-axis. When I go to do 28, to find this function, the base is going to be 2. The x plus 2 is going to be in the parentheses in the exponent, and it really doesn't have to stay in the parentheses. The minus 3 is going to come after the function. This plus 2, when I go, so this is for 28a, that would be my whole answer for 28a. When I go to describe the transformation in 28b, the plus 2 inside the parentheses is going to move it left 2. The minus 3 after the function is going to move it down 3. Again, you should have this chart either in front of you so you could reference it, or have it memorized. We've done a lot of this chart already, so hopefully you kind of have it memorized. All right. For finding each function here, g of x minus 3, since g of x equals 2 to the x, g of x minus 3 plus 1, the x minus 3 is going to go in the exponent. The plus 1 is going to go after the function. That's my answer to 30a. The x minus 3 is going to move it right. The plus 1 is going to move it up. So when I go to do part B, I'm going to say it goes right 3 and up 1. And then lastly, 32. Since when I go to do part A, since g of x equals 2 to the x, negative g of negative x plus 1, I'm going to have a negative in front of the 2 to the x for that negative, a negative in the exponent for that one, which I could put in a parentheses, but I don't have to, and then the plus 1 after the function. That negative reflects it over the x-axis, that negative reflects it over the y-axis, and that moves it up 1. So I'm going to, for my answer to part B of 32, I'm going to say reflect over both x and y-axis, and then up 1. It's probably a good stopping point for this video. So I'll stop it here. I've got to have another part to do here in a second.